Welcome to 5G Technology World. I'm site editor Martin Rowe. Industrial IoT includes measurement devices and systems that monitor the health of equipment. Devices are often battery-powered, taking periodic measurements on phenomena such as temperature, level, flow, and weight. These devices often need wireless connectivity to transmit data to a central location. Today's guest on 5G Technology World is Harold Remmert, Senior Director of Technology at Digi International. He has over 20 years experience in IoT and industrial connectivity, covering product strategy, design, development, and test. Digi International specializes in industrial IoT products such as embedded systems, network components such as industrial gateways, and IoT software. Harold has overseen the wireless at Digi for over 10 years. Let's start with connectivity. Why do IoT and measurement devices need connectivity?
Our customers have a variety of different reasons why they want to connect devices. So in some cases, they just want to get better insight into what a connected device is doing, right? So is it running fine? Is it having a problem? If these devices are remote, then they would like to limit the amount of site visits. By doing that remotely, that's definitely a benefit. Also, in today's times with COVID, it's also fewer site visits means that people are safer, right? So less exposed, they want to know if the equipment is running as expected, or if it requires additional hand-holding. They also want to save cost, of course, right? So every truck roll means cost. Every person having to inspect an equipment means cost. And so if you can do that remotely in a centralized location, that's much more cost-effective.
Can you tell us different ways that some of this equipment is connected back to a network from a remote location, specifically focusing on cellular?
Yeah. So traditionally, there is the wired connectivity. Well, for wireless, you have really three options. So satellite being one, usually slow, very expensive, has high latency. Private radio networks are another option, and so traditionally, there have been these networks with Zigbee, LoRa, etc., or other proprietary standards, but also based on cellular technology, right? So a company might take out or may license spectrum from a mobile network operator, right, and operate it, for example, for an oil field. Typically, these private radios are a little bit more complex to set up. The range is limited, and you still need a backhaul, right, to get from your local network to like a central location. Cellular really is a great fit. It's available almost everywhere. These days, it's fairly inexpensive with some of the newest cellular technologies around LTE-M, MBRT. It's super reliable. It was built for reliability. It's very scalable, and it's also can be very fast.
Okay, can you tell us a little bit about how 5G is coming into play?
Mm-hmm. So it's an interesting question, because when customers think about 5G, they the first applications are really driven by high bandwidth, right? So you have the smartphones kind of driving like previous cellular technologies, kind of driving the industry. But where 5G really comes into play for industrial applications is bandwidth is one thing. So for example, if you want to monitor a site or monitor a process and use, for for example, optical inspection, you can, with 5G, you can use a high resolution camera, like a 4K camera, 8K camera, to get more details within that application. The second part is really where 5G comes in, is lower latency. So instead of having latencies around 50 to 100 millisecond round trip, you can get down into the single digit latencies. And what that allows you to do is you can really more interactively command and control versus just to remotely monitor.
5G has a number of flavors, but two in particular, the low band, mid band, so-called sub-6 gigahertz, and the millimeter wave. When do you need to use the millimeter wave, given that it is not nearly as available and it has a shorter range than the sub-6?
Mm-hmm.
Do you expect that to be used much, or do you think that most of the uses, at least initially, will start out as sub-6?
Yeah, so the millimeter wave is, and the super high bandwidth and the super high speeds that it brings, right? Multi-gigabit speeds, even, I mean, in the final build out of the stand, it's up to 20 gigabits per second, right? So that's really a great replacement for high-speed links like fiber links today, right? But as you already said, they're very limited in space. So really only super high speed is where these become more interesting. Sub-6, on the other hand, provides both the coverage and the capacity within the 5G network. So we expect, and we believe that the big benefits will come with sub-6 and with some special applications for millimeter wave. You can also see this when you watch the spectrum auctions that are going on. Just the recent ones in the US with for the CBRS midband, and then the PAL auctions around that, and then now the C-band, which was just completed in 2020, early 2021. Carriers are spending a lot of money on those mid-band spectrum because they know that that's where the majority of the applications lie.
Do you see 4G being used for a very long time yet, or are you starting to see 5G applications coming into play?
So we believe that 4G is going to be around for a very, very long time. So at least for another decade. And this is really based on two different data points. One is when you look back at previous generations of cellular technologies, they typically took a decade to build, and then they lived on for another decade, and then they started to decline and fade out. The other data point is with 4G and 5G, what the carriers are deploying is done a technology called dynamic spectrum sharing. And so what that allows the carrier to do is to use the same spectrum that they're using for either 4G or 5G. So unlike previous approaches where, let's say, when we moved from 3G to 4G, the carriers really had to reform spectrum and take spectrum away from 3G to apply it to 4G. So with this dynamic spectrum sharing, the carriers can offer both technologies basically on the same spectrum and dynamically allocate it. And right now, most of this, the devices will be 4G devices, right? And over time, that will shift to 5G. Gives 5G a great head start, right? So you can get 5G nationwide very quickly, and provides longevity for 4G devices because carriers really don't have to shut off spectrum. So it's definitely a great technology. So we believe 4G devices and the technology will be around for at least another decade. and then 5G will ramp over the next decade.
There are many devices that are still connecting to cellular networks over 3G.
Mhm.
We keep hearing about 3G is going into sunset. Whether it is or it isn't is still debatable. But let's assume that it is. It's going to be eventually.
Mhm.
So when would you recommend, if someone says, okay, I've got to get off 3G, would you recommend going to 4G or 5G? And it may depend, it may be very application dependent, but when would you say to someone, you should really just go directly to 5G, or when would you say 4G is going to be around long enough, you can go with 4G? What would be some of the factors that come into
Yeah,
play?
it's a very good question. And the answer is it depends. But the factors that that play into that are really first is the customer's application, right? So can they benefit from 5G today? So higher speed, lower latency. Or is that something that they might need in 5 years or more time? Sometimes taking a step from one technology to the next, and then so from 3G to 4G, and then from 4G to 5G, having this interim step might still make sense. It depends on where the customer needs the cellular technology, right? So if it's, for example, in a urban application, 5G will most likely be there. If it's out in the field, you might not get it right away. Also, the cost of 5G devices today is still very high because all of the new 5G modems that are coming have come out, and devices that are coming out, they're still at the very high end. And when you look at the smartphones today, there's an indication that you get the flagship smartphones have 5G, right? Then, and over time, over the next couple of years, 5G will kind of flow down into the more affordable and lower cost phones. And so it's the same with in the industrial space. So so there's a price premium, and if a customer has an application that requires like high speed or ultra low latency, then this price premium makes sense. If they don't need that right now, then our guidance typically is, hey, maybe a 4G device or 4G as a technology is still the better solution. And because that one is proven, it's reliable, right? So you have customers have options from all the way in the low end, from LTE, Cat 1, LTM, even below that, NB-IoT, all the way to gigabit speeds today, right? So invest in that, and then maybe in 5 years of time or so, invest into 5G. There is one theme we're seeing with customers, though, is so if they, let's say, have a want to deploy a technology and they know this asset will be around for a very long time, then let's say a decade or more, then they might choose 5G now because they know the network will grow, the devices will grow, right, as through device updates, firmware updates, and they're ensured that they won't have a 4G shutdown.
Another aspect of 5G is edge computing. Can you cite some examples, some industrial examples of where edge computing might be used?
Yes. So the benefit of edge computing is to have the control and the compute near the device. And when you one of the benefits is that you have really low latency, so you can do instant decisions, and you can also transfer a lot of data. For example, if you have a application that today in a 4G infrastructure that maybe is sitting on the West Coast, and then you have a data center on the East Coast, then if you want to have do a command and control application that that data has to traverse the United States, right? And then you process it, and then maybe you want to send a command back. So if you do it that way, then you have several hundred milliseconds of latency. If you put the application right on the cell edge, right next to the cell tower in a data center, then you can act almost instantaneously, right? So the data arrives at the cell tower, gets to the edge data center, gets processed, and then gets sent back. So this is important for applications that require ultra low latency, such as industrial control applications, for example.
Can you cite some security issues that might come up in connecting these industrial devices?
Yeah, so the biggest is really bad actors, hackers, getting access to an asset, right? And I guess in the best case, they only get access to the asset. They might be able to read some information, but they cannot do any harm. What's even worse is if they get access to an IoT device and then you can use that as a backlink to get into the broader system and infiltrate the broader system, or if they can modify a device in a way that for example, just recently in Florida, there was a hack, right, where a hacker released some chemicals into a water treatment strain, right? And so that would have been, if that would not have been detected, luckily, then they would have done really, really big harm. So having secure devices from the start and then keeping these devices secure over the life cycle of the device, that is very critical.
How can 5G be used with these industrial devices in terms of automation?
So one of the benefits of 5G is the low latency. Instead of having all the control locally on the device, you can extend it to the edge where you have more processing power available. And so, for example, your device can become smaller, can become leaner, and that interaction between the device and the edge helps with automation because you have all the compute power. For example, if you want to do a visual inspection, right? So the device monitors the data, for example, an area, right? And when it finds something abnormal, it sends that over the edge analyzes it, and then sends it back and takes appropriate action, for example.
Okay. How can engineers get control or be able to manage some of their devices through when running, let's say, a cellular connection, though not necessarily? What kind of control can engineers get out of from their devices?
Yeah, so I think the key is if you have one device, you can connect to it directly, right? And maybe do some tweaks on the device. But but that's really the exception. What we typically find is that customers have hundreds or thousands of devices in the field that they have to manage and monitor. And so for that, it's really important to have secure out-of-band management to these devices. So from a central location. So for example, as a network technician, I want to see if the device works properly, or if it doesn't, right? Then I want to have a secure connection to my device, and in order to see what's going on. And then I want to see this only for the devices that are really in trouble. For the devices that are running normal, I know they're running normal, right? So I don't have to take any action. So that really helps by having this centralized and secure way of accessing devices. I can optimize my time, and I don't have to worry about things that are working fine.
Harold, can you tell me a bit more about resiliency? What do you mean by that? And what do engineers, technicians need to know about having that kind of resiliency?
Mhm. Yeah, that's an important one because so what resiliency is really a way to get the device back online in case of a failure. And so this could be anything from hey, it's like human error. Hey, somebody configured a device, right? And oh, they might have misconfigured it. It might be a environmental issue, a power glitch, cellular network issue, for example. And so all these issues could result in the device not staying connected or being connected anymore. And so it's really important to think about measures, how and design resiliency into the product so that when it falls down, it gets back up on its feet. So things like, for example, having multiple SIMs available for failover, being able to auto detect the carrier that, for example, the mobile network operator that a device is using, and based on the SIM, and then looking at and probing some common APNs, or having a backup configuration very easily, being able to power cycle to monitor, hey, is this device doing what it's supposed to be doing? Or if not, power cycling it and bringing it up to its feet. And then lastly, connecting in this for if you have central device management, and being able to, for the device to automatically connect back and report that, hey, there was an issue here, right? Maybe a technician should take a look at it.
Harold, thank you for being with us today. For 5G Technology World, I'm site editor Martin Rowe. Thank you for watching.